Hi, I'm Miss H, and today we're going to be looking at the relationship between mass and volume. Before we can look at the relationship between these two, we need to know what they are. Mass is the amount of stuff or matter that a substance contains. This means we're looking at how many atoms or molecules of that material the substance contains. The unit for mass is some form of grams. We'll usually use grams in our class, however, kilograms or other units are also acceptable. The variable for mass is a lowercase m, and we measure it using a balance. If you remember from our previous videos, volume is the amount of space that a substance occupies. The unit for volume in our class will usually be either cubic centimeters or milliliters. They are interchangeable, meaning that 1 cubic centimeter is the same as 1 milliliter. There are also other units for volume that are acceptable as well. When we put volume into a formula, we represent it with a capital V, and we measure it using either a graduated cylinder or a ruler. Now we want to look at the relationship between these two. In order to do this, we took 10 metal cylinders, 5 light and 5 dark. Since the size of the cylinder was what we controlled, we put the volume on the x-axis, and the mass as our dependent on the y-axis. We found that our 5 dark metal cylinder dots and our 5 light metal cylinder dots fell into 2 nice straight lines. We then calculated the slope of these lines simply using rise over run, and found that our dark cylinders had a relationship or a slope of 7.8, and our light cylinders had one of 2.7. Because our slope was simply rise over run, we looked at this as mass divided by volume. This relationship we already know exists in science, and we call it density. Density is a measure of a substance's compactness, or a ratio of its mass to its volume. The denser an object is, the more mass is in that same amount of space, or the more stuff is in that same amount of space. Density is measured using your mass unit divided by your volume unit. So for our class, that will usually be grams per cubic centimeter or grams per milliliter. You can read the word per as meaning for every. So if a substance has a density of 5, that means that for every milliliter, there are 5 grams. In a formula, we use a capital D to represent density. And density, of course, is calculated and not measured directly. In order to calculate it, we need to have a formula. And the formula for density is simply the slope formula we just found on the previous slide, mass divided by volume. Now we want to take a look at some density problems. To solve these problems, it takes 4 simple steps. The first step is to identify the information that the problem gives you and what information the problem is asking you to solve for. The second step is to write either your formula or triangle. Then plug your numbers into that formula, and finally solve it. Now you'll notice in step 2 it mentions a triangle. What exactly is a triangle? A triangle is something that allows us to solve problems more easily, or acts as a shortcut. So when you write a triangle, you start by drawing a horizontal line to represent division, and a vertical line to represent multiplication. Because your m is a numerator, it has to stay in the numerator position over here, leaving d and v to go in the bottom. If we cover up our d, we see that we get m divided by v, which is what we see here. If we'd put our m in any other position, we would not have gotten this formula back. If we cover up our m, we see that we end up with d times v. And if we cover up our v, we see that we end up with m divided by d. So this triangle just simply allows us to rearrange our formulas without having to actually go through the process of rearranging them. Let's take a look at some examples. A 20-gram rock is placed into 100 milliliters of water, causing the level to rise to 110 milliliters of water. What is the density of the rock? So step 1 is to identify what information you've been given. In this problem, we see that you've been given a mass of 20 grams. We've been given a volume of 100 milliliters. And we've also been given a volume of 110 milliliters. And the problem is asking us to solve for the density of the rock. Next, we want to figure out what formula we want to use. The formula, as you'll be given it on your reference table, is m divided by d equals m over v. So we don't actually need to rearrange it since d is what we're solving for. However, you'll notice that there are two v's over here and only one v in here. Remember that the volume of the rock is equal to the volume after the rock was added minus the volume before the rock was added. So after it was added was the 110, and before it was added was the 100. So V equals 110 minus 100, or 10 milliliters. Now we can use that V for our formula and plug in. So we have our 20 grams over our 10 milliliters. And we find that our rock has a density of 2 grams per milliliter. Let's try another problem. A 97-gram block of aluminum is going to be used to determine the density of aluminum. The block measures 6 centimeters by 2 centimeters by 3 centimeters. What is the density of aluminum? Step 1, identify what you've been given. So here we have our mass. And then here we have a chain of numbers, 2 by 3 by 6. If you remember from your math classes, to find the volume of a rectangular prism, you take length times width times height, which is basically what we're seeing here. So this is telling us that our volume is going to be 36 cubic centimeters. 36 because 6 times 2 is 12, times 3 is 36. We also want to, in step 1, identify what the problem wants. In this case, that's density. And in step 2, identify what formula we're going to be using. Again, since this time our formula is written exactly as it is on our reference table, we don't need to worry about our triangle, although you could use it if you wanted to. So now we have 97 grams over 36 cubic centimeters, and that gives us 2.7 grams per cubic centimeter. So we can see that our light-colored cylinders were most likely going to be aluminum. Let's try a different problem now. The gemstone opal has an average density of 2.2 grams per cubic centimeter. What is the volume of a 0.5 gram opal? Again, in step 1, you're identifying what information you've been given in the problem. So here we see two numbers. This one is measuring grams per cubic centimeter, so that's a density. And this one is measured in grams, so that's going to be a mass. We also want to identify what is the question, and the question is volume. At this point, you can either use the formula as is and rearrange it to solve for V, or you can use your triangle to solve for V. And you find that V is m over d. So that's 0.5 grams over 2.2 grams per cubic centimeter. And you find that V is 0.23 cubic centimeters. Now let's try another one. What is the volume of a 5 gram gold nugget? Gold has a density of 19.3 grams per cubic centimeter. Step 1, identify. my density. That's going to be my mass. What do they want? And what formula should I use? Again, you can start with the original formula and just rearrange it to solve, or you can plug into your triangle. And we find that our volume is 0.26 cubic centimeters. Here's a different kind of problem. What is the mass of a marble that has a density of 3.6 grams per cubic centimeter and displaces 0.75 milliliters of water when placed in a graduated cylinder? Even though we're now solving for something different, we're going to start it the same way, by identifying what we're given and what the problem wants. We're given a density and volume and asked to solve for a mass. For your formula, you can either keep the original and rearrange it, or you can put it into your triangle. And solve for m. 3.6 times 0.75 gives us 2.7 grams for our mass. One final problem. Garnet has a density of 3.5 grams per cubic centimeter. What is the mass of a garnet that has a volume of 0.05 cubic centimeters? Start by identifying what you've been given and what you want. And then figuring out what formula you need to use. So we end up with mass is density times volume. So 3.5 times 0.05. We end up with 0.18 grams for our mass. That's everything you need to know about the relationship between mass and volume and how to solve density problems. As always, if you have any questions, feel free to send me an email.